Hello, and welcome to Lecture 1 of Electric Interactions in Phys 1204. In this lecture, we're going to establish a model for why some things exert electrical forces on other things. The first thing we're going to do is establish an operational definition of charge. You may not know what I mean by an operational definition. An operational definition is just a definition of something that we state in terms of practical things we can do or things we can observe. The piece of plastic and the piece of wool will not pick up these pieces of paper, but if I rub the plastic with the wool, then after rubbing, the plastic will pick up the pieces of paper, and the wool will pick up the pieces of paper. This, then, is a practical procedure and set of observations that we can use to define what we mean by charge. Charged objects exert electrical forces on uncharged objects, and so in this case, after we had rubbed the rod with the wool, it was able to exert an upward electrical force on the paper, and thus pick the paper up. It's convenient to test this using something like the paper because the paper is very light, and so it's easy to pick up. We could do an even more sensitive test using dust. You can see here that the plastic rod will also exert a force on a stream of water, and so will the piece of wool. Uncharged objects don't exert electrical forces on each other, so the paper sitting on the desk isn't attracting the other paper on the desk, and before we rubbed the rod, it also exerted no force on the paper. Notice that electrical forces are field forces. The paper actually jumped up off of the desk to stick to the rod. No contact was necessary for the rod to exert this force. The other thing to keep in mind is that Newton's third law must still apply, and so although it's harder to observe it, the paper must have been pulling down on the rod with an electrical force. This is an interaction pair. We say that there is an electrical interaction between charged objects and uncharged objects. As another example of this, when you tear off a fresh piece of Scotch tape, rather annoyingly sometimes, it tends to be attracted to your hand. Does this mean your hand is charged? No, you can test it out. Your hand doesn't pick up the little pieces of paper, so it's not charged. But the tape does. That's the non-sticky side of the tape that's just picked up that paper. There's some terminology that you need to be familiar with. When an object interacts electrically with other objects, we say that that object is charged, or we say that that object has charge. An uncharged object is referred to as neutral. And charged objects don't remain charged. They eventually return to being neutral. So, for example, if you take your charged piece of tape and stick it to the edge of a desk, and leave it for a while, it'll eventually lose its charge. Or you can speed up the process by touching it all over its surface, and then you'll find that it's no longer attracted to your hand. The process by which a charged object returns to being neutral is called discharging. It's really important to note that electrical forces are not the same as magnetic forces. These are two totally different phenomena, although as we'll see, they are connected. A magnet is very different from a charged object. There are lots of things it'll pick up. For example, this permanent magnet will pick up various pieces of steel. However, it will not pick up the little pieces of paper on the tabletop, and so it doesn't pass our test for being charged. So magnets do not pick up light neutral objects like paper. They only pick up very specific things like steel. Also, there is such a thing as a permanent magnet, which will maintain its magnetism for a very, very long time. But charged objects always discharge. So these are just some ways that electrical interactions are different from magnetic interactions. We'll see more differences later in the course when we study magnetic interactions in more detail. We've already seen that tape that's been freshly peeled off of its roll is charged. It picks up paper and it's attracted to your hand. Let's do an easy experiment to investigate this further. And this is such an easy experiment, you should really go grab some tape, and you'll need some pens, and do this experiment along with the video. The best type of tape for it is the type that's marketed as magic tape, but any sort of clear plastic tape will work. Start by laying a layer down on the desktop. This is just so that you have a layer that you can put other layers of tape onto and then peel them off of it in a dependable way. With all the other layers you work with, you'll want to fold their ends over so that you have a nice little handle, and also so that when you stick them down on other layers, you have a piece that doesn't stick down that you'll be able to peel up. So now you can peel them up quickly. What you'll find with that layer that you peeled off the base layer is that it's charged. Just like before, no surprise, you can pick up bits of paper with it and it's attracted to your hand. But now do a relatively delicate operation. Prepare 2 pieces of tape this way. Weight the ends with paper clips, then peel them off. Then you find that they repel each other. We haven't seen that before. We haven't seen that charged objects will repel. But these 2 pieces of tape repel each other. And if you touch them, as before, you can make them discharge, and this repulsive interaction between the freshly peeled tape will go away. So what we've just seen is that 2 pieces of tape that are similarly prepared repel each other. Contrast that. Both pieces of tape are charged. They will attract neutral things, but they repel each other. This is a new behavior that we haven't seen before. We can see something even more important if we use 2 strips of tape. So, lay down a strip of tape and label it. Label it with a B for bottom. Now lay down another layer on top of it and label that one T for top. Peel the 2 layers up together. Peel them slowly, making sure that they stay stuck together. And then stick them to the edge of a desk and discharge them. Now we have 2 layers of tape that are stuck together and are discharged. They're neutral. Peel the top layer off of the bottom layer and stick it to the desk too. Now you'll notice that both of them, the top and the bottom, are both charged. They were neutral before we peeled them, but now they're both charged. The fact that both of these pieces of tape, the top and the bottom, are both charged is actually something we've already seen in a different case, because when I rubbed a plastic rod with wool, what we saw afterwards were that both the rod and the wool were charged. If you bring the top and the bottom pieces of tape together, you'll find that they're attracted to each other. Remember that before, when we had 2 pieces of tape that we'd prepared in identical ways, they repelled each other. But now we have 2 pieces of tape that we've prepared differently. One of them was peeled off of the other, and we see that they attract each other. This is something complicated going on, and we need to investigate it further. Make 2 pairs of top and bottom strips. Peel them both. When you peel off the second top, test it. It will repel the other top and attract the other bottom. Now test a bottom. It'll attract the top and repel the other bottom. What this and many other experiments show is that there are 2 kinds of charge. Let's summarize what we've seen. We've started off with a top piece and a bottom piece of tape stuck together. And it's neutral. It does not have any electrical interaction with other neutral objects like your hand. Then you peel them. You now have a top piece and a bottom piece. Now, both of those are attracted to neutral things like your hand, and so we conclude that they're both charged. However, their charges are different somehow, because bottom pieces always repel other bottom pieces. top pieces always repel other top pieces, but bottom and top pieces attract each other. And so the charge on the bottom pieces must be a different kind of charge from the charge on the top pieces. We've got two kinds of charge here. Well, let's check whether you're understanding things. And you can try this out at home if you've been doing the experiments with the tape so far. You can easily charge a comb by running it through your hair a few times. And once you've charged it, of course, you can verify that it's charged because it'll pick up little bits of paper. And if you've made a top and bottom piece of tape, then you will find that the comb will repel the bottom piece of tape and it'll attract the top piece of tape. So the question is, does the comb have top charge or bottom charge? So if you're in this course and doing this through Moodle, Moodle will now ask you this question before allowing you to go on to the next half of the video. If you're not in my course, I would encourage you to come up with an answer anyway before you click on to the next video.